Okay, so today we are going to discuss the introductory portion of rolling contact bearing. So bearings are generally parts that are used to reduce the friction in machine components. Okay, it permits the relative motion between two components in a machine. So rolling contact bearings are also known as anti-friction bearings because of its low friction characteristics between ball and inner race and outer ring. Here the picture of a rolling contact bearing is shown, specifically a ball bearing. This inside ring is called inner race and the outside ring is called outer race, and in between these two races there will be rolling elements inserted, and to hold them in position there will be a cage or separator between these elements. So how these bearings are installed on a machine? This inner race, inside this inner race, the shaft is inserted, and the outer race is assembled with the frame of a machine. Okay, and outside race is attached with the fixed frame of a machine. Okay. So while in motion, this outer race will be stationary and this inner race will be rotating with the shaft, and this rolling element will permit the relative motion between these two components. Different forces are acting on a rolling contact bearing are radial load and axial load. There might be chances that a combination of both loads can be acting at a time on a bearing. Now, as you can see in this picture, in ball bearing, there will be a point contact between the inner rotating element and the races. So, because of this point contact, the friction developed in these elements or in these bearings will be very less. You can say it is a negligible. Different rolling elements that can be used in these bearings are ball and rollers. Okay, in this picture, I have shown the ball bearings. Okay, this element is a ball, that is why it is called ball bearing. If we replace this ball with rollers, then it will be called as roller bearings. The components of these ball bearings are shown over here, or you can say the cut section is shown over here. You can see this is the inner race and this one is the outer race, and in between these two races the ball is inserted. Okay, you can see the number of balls are inserted, and to hold these balls in their position this cage or separator is provided, or you can say retainers are provided. Okay, so these balls don't fall down due to gravity. Okay, to hold them in position these separators are provided. This is the internal diameter of the bearing and this one is the outer diameter of the bearing. This is called face of the bearing. Now let us discuss different types of rolling contact bearing. The first one is deep groove ball bearing. Okay, this is the simplest and widely used bearing, deep groove ball bearing. This a simple ball, spherical balls are inserted between the races, and to hold them in position, this cage or separator is provided. In deep groove bearings, balls are fitted well into the deep grooves. Okay, you can see this groove is deep, enabling the bearing to support axial loads in both directions. Okay, this kind of bearing can take load in radial direction, means in this direction, as well as somewhat amount of load in axial direction. Generally, ball bearings are preferable in at high operating speed with small loads. If loads are higher, then we have to replace these balls with rollers, that we'll discuss in this lecture only. Okay. Next is angular contact ball bearing. Okay. Previous bearing, that is simple deep groove ball bearing, can take load in radial direction, major load in radial direction only, okay, and minor load in axial direction. But if the load is acting at some angle on this ball, then this arrangement cannot be used. Okay. At that time, we have to change the shape of outer and inner rays. Closely look at this, the shape of inner and outer rays. Okay. So as you can see, the inner rays is given a different shape and the outer rays is also given a different shape as compared to simple deep groove ball bearing. This kind of bearings can take the load at some angle. Angular contact ball bearings are able to withstand a large thrust load in a single direction in addition to radial loads. Okay. It can take radial loads and it can take thrust load, means axial load, in one direction only. Okay. You can see from this picture, if the load is acting from right to left, then it can resist. But if the load is acting from left to right, then the ball will escape from this space. Next is self-aligning ball bearing. Okay. This self-aligning ball bearing can accommodate for some minor these ball bearings can accommodate for some minor misalignments between the hub and the shaft. Okay. These are self-aligning. In self-aligning ball bearings, there are two sets of balls in which one run on a pair of grooves on the inner ring with a single outer ring of concave surface. You can see that the inner ring is having a different shape. It is having two grooves to accommodate two rows of these balls, and the outer ring is having a single curvature of spherical shape, or you can say concave surface. This bearing accommodates for minor misalignment. Next is cylindrical roller bearing. In this bearing, the rolling element is changed from a spherical ball to a roller shape. Okay. These kind of bearings are able to take larger amount of radial forces as compared to ball bearings. Okay. So in applications in which the radial loads are high at high speed, then you have to use roller bearings. In roller bearings, the contact will be line contact as compared to point contact in ball bearing. So these bearings will take higher amount of load. The cylindrical roller bearings are able to withstand larger radial loads. The bearing illustrated is a single row bearing. There may be double row for heavier applications. This bearing played a seminal role in development of continuous rolling mills. Okay, this type of bearing, roller bearings, are extensively used in rolling mills. Next is spherical roller bearing. Okay. In this, we are slightly changing the shape of roller from cylindrical to spherical. In this spherical roller bearing, there is an angle contact between the roller and raceway. The bearings are able to withstand both axial and radial loads. The double set of rollers in spherical roller bearing permits the bearing to accommodate shaft misalignment. Okay. So as you have seen, when we are using two rows of rolling element, these bearings are used for accommodating slight shaft misalignments. Okay, so when there is a misalignment present in the system, then you have to use either spherical roller bearing or this self-aligning ball bearing. If the loads are higher, then you have to go for this one. Okay, spherical roller bearing. Next is taper roller bearing. These taper roller bearings are designed to take radial as well as axial loads. Because of this taper, these bearings are able to get higher amount of axial load as compared to this previous discussed bearings. In tapered roller bearings, the inner and outer rings and the rollers are tapered. Okay, you can see the shape, these are tapered in order to simultaneously support axial and radial loads. In these bearings, the ratio of axial and radial loads supported depends on the angle between the roller and the bearing axis. If we increase the angle of taper, then we can take higher amount of axial load. Next is needle roller bearing. Okay, in this we are changing this rolling element to a needle shaped element. If you see these rollers, these are having a higher radius. These rollers are having a higher radius, while when you see the needle, then the radius of this roller is smaller. That is why this shape is same as needle. So that is why these are called needle roller bearing. These bearings are used. In this bearing also there will be a point contact between the elements, or we can say inner race and rolling element. These bearings are used where we are having limitation of space in radial direction. Okay, if we are having less space available in radial direction, then we have to use this needle bearing, because this roller bearing will not fit into that space. So whenever there is a lower amount of radial space available, then we have to use needle roller bearing. Now these bearings are having long and thin rollers. These rollers are thin and long. These bearings are used for the applications where radial space is limited. Okay, next is thrust bearing. Thrust bearings are designed to take only axial loads. Okay, you can see the difference between the construction. You can compare these two images. This one over here is, let me use the pointer, better help you. Okay, this bearing over here is a ball bearing which is designed to take radial loads. Okay. So radial load will be coming from this direction and axial load will be coming from this direction. Okay, these are designed to resist radial force. That is why these balls are placed in this position. Means the load will be acting from outer race to the ball to the inner race, or in reverse order from inner race to the ball and to the outer race. Now if you look at this bearing, thrust bearing, thrust force means the force acting in axial direction. Okay, so this bearing will support the forces in axial direction only. So if a force is coming from upward, then it will first act on this upper race, then it will be transferred to balls, then it will be transferred to lower race. Okay. And to support the relative motion between the shaft and upper surface and lower surface, we are inserting these ball elements, and to hold them in position we are using this cage. So thrust ball bearings can support an axial load in one direction. These bearings are designed not to accommodate radial loads. Okay, this bearing, thrust bearing cannot take radial loads. The component of this bearing can be easily separated. Okay, dismantling the thrust bearing is quite easier as compared to these radial or roller ball bearings or radial bearings, you can say. Okay, so this was about different types of bearings. Now let's have a look at to select how do we select the bearings for a particular application. These are the 5 important features for selection of type of bearing. First one is magnitude of load. Okay. Magnitude of load. This is a very much important criteria while selecting a bearing for particular application. If we have to support small loads in radial direction, then we have to use ball bearings. If we have to support higher amount of load, then we have to go for roller bearing. In radial direction I am talking about. If I want to support, if my load is acting okay, if my load is acting in axial direction, then we have to go for thrust bearing. I am talking about this point, direction of load. Okay, so it is important criteria to decide the selection of bearing. The direction of load means from which direction load is acting on the bearing. If the load is in radial direction, then we have to use radial bearings. And if the load is acting in axial direction, or you can say thrust load, then we have to use thrust bearing. If the load is acting at some angle, then we have to use angular roller bearing or angular ball bearing or self-aligning ball bearing. Okay. Next is drive condition. Okay, drive condition means in which condition our bearing is going to work. Okay, means if, say for example, we want to use a bearing in a car, then we have to take into consideration the road surface conditions. If it is a very rough surface, then there will be up and down movements of wheels, and in wheels bearings will be fitted. Okay. So at that time we have to select self-aligning bearing or roller bearing. Okay, so that is the condition of drive. Then rigidity of drive. If you want higher accuracy, rigidity of drive means how rigid our drive is. If my drive permits flexible movements, then I have to use self-aligning bearings. If I want to use it rigidly, then I have to use roller bearings. For example, if I want to develop a machine in which high precision is required, then at that time, or high precision and high tolerance is required, then at that time we have to use rigid drive. Okay, so roller bearings provides the rigid drive. Next component is noise. Okay, very important feature while selecting the bearing. Okay. Ball bearings are generally used for applications that are producing lower noise or less amount of noise. Ball bearings are quite in application, but this is also depend on the working speed. Okay. Ball bearings are quiet at low to moderate speeds. At very high speed, these ball bearings will create huge noise. If your component is working at very high speed, then the journal bearing will be more beneficial. Okay, because we can lubricate between these journal and shaft, journal and bearing, so that will reduce the noise. But these bearings can be quietly used at low to moderate speeds if we are talking about noise point of view. So these are the important features that are responsible for selection of which kind of bearing should be used in our application. Okay, so that's it for today's lecture.